So we're going to look at linear relationships today, basically dealing with slope and y-intercept and writing that equation. So just a reminder, our equation is y equals mx plus b, where m is my slope and b is my y-intercept. Now, whenever I'm trying to find my slope, obviously I have this table here. So to find my slope, I have to do that change in y over change in x. This would be my change in y over here. This would be my change in x over here. So I would find the difference between these two. Basically, you can do 1550 minus 950, and that gives me a difference of 6. So my change in y is 6. To go from 2 to 4, I change by 2. So I know that my rate of change, my slope, would be 3. Now, to find my y-intercept, I always want to know when x is 0. So if this row is x, this row is y. I want to know when x is 0, and that will tell me what my y-intercept is. So in this case, it's very easy to work backwards, because if I work up by 2, that gets me to that 0. So if I work up by 6, if I do 950 minus 6, that gives me 350. So I know my y-intercept would be 350 because that's when x is equal to 0. So if I have my equation y equals mx plus b, I know my slope was 3. So I have 3x plus 350, and I can always try that out and see if it works by using my x value and using my equation. So you can always check your equation and do 3 times 2 plus 350, and if you do that, it does give you that y would equal 950, which is correct from my table right here, that when x is 2, my y is 950. So when I put 2 in for x, I got 950 for y. So on this next one here, I've got to do rise over run to find the rate in which the tree is growing. So if I do rise over run, notice again, my scale is not going by 1, so I have to be very careful here. So if I pick this dot right here, I'm going from 18 up to 24. So I am rising 5. No, just kidding. I'm rising 6. I can't count. I'm rising 6, and I am running. If you notice each of these, it's 2, 4, 6, 8. So I am running to 4. So I have 6 over 4 is my slope. And that simplifies down to 2. Oh, man, I cannot math right now. Sorry. 3 over 2. So I know basically you could use 3 over 2, you could use 1.5, all the same thing. And then I've got to find, to be able to write my equation for my graph, I have to know my my slope. So my slope is 3 over 2. My y-intercept is where it hits my y-axis right here. So my y-intercept is 12. So my equation would be y is equal to 3 over 2x plus 12. And then it says, is the graph proportional? So remember, for something, don't get proportionality and functions confused. Remember, functions are just determining if my x's repeat. Proportionality means that the graph has to go through the origin and it has to be a straight line. And since this is hitting the y-axis at 12, it is not going through the origin. So this graph is not proportional because it does not go through the origin. Now, it is linear, but it has to meet both criteria. So if we go to look at our kind of little cheat sheet that we have here, we have, again, our slope is our m, and our y-intercept is our b. Our slope is that change in y over change in x, our rise over run, and the y-intercept is where it hits the y-axis. So if we had a line with a slope of 8 and a y-intercept of -10, my equation would be y equals 8x minus 10. If I had an equation of y equals -3x plus 5, I know that my slope is -3 and my y-intercept is 5. Now, over here to the right, whenever it is talking about writing equations, to find your slope, you can do this y2 minus y1 if you understand that equation. If not, basically what this is it is my change in y over my change in x. That's all it really is. It's your rise over run. It's all of that stuff there. And your y-intercept is when x is equal to 0 or where your graphed line crosses the y-axis. And you can always write your equation in y equals mx plus b form like we did up there at the top. So like on this one here, if I do my rise over run, I rise 1, that's where you get your 1 here, and I run 2. So I have my rise over run, and then my y-intercept is right here where it crosses the y-axis. So your slope is your m, your y-intercept is your b, and that's how you get that 1/2 x plus 1. Your example 2 of the, with a table, you would have to do your change in y over here, which would be 8, and your change in x, which would be 2. So your slope would be 8 over 2, which simplifies down to 4, which you have there. And then to find your y-intercept, it's when x is equal to 0. So in this case, they gave you that, they gave you x equal to 0, so you know your y-intercept is -9, and that's how we get that 4x minus 9. Now with proportional, non-proportional. So a relationship is proportional if there's a constant rate of change between x and y. There has to be a constant of proportionality. So in a graph, we know that it has a constant rate of change by knowing that it goes through the origin and it is linear. If it does not do both, then it would be not proportional. In a table, we can try y divided by x, and if we get the same ratio every time we do y divided by x, we know that it is a proportional situation. If we do not get that every time, then it is non-proportional. And then we can always look at an equation, and if they say y equals kx, but y equals kx is the same thing, that k is the same thing as saying like y equals mx, you just don't have a y-intercept, which makes sense because on the graph, it has to go through the origin. So if we're adding on 0, we wouldn't have that plus b on there. And so if it is not proportional, then you have that plus b. Now, let's talk a little bit about direct variation. We really didn't teach you a whole lot about direct variation. And this is just going over a little bit about direct variation. So if y varies directly with x, it is a proportional relationship where y equals kx. K is called the constant of proportionality or constant of variation and is also equal to the slope. So to solve for k, you can divide y divided by x, and that will tell you what your constant of proportionality is. So that's really not anything too much that you have to really worry about. We're not going to quiz you over it, but it is something that just to show you. Now, the next thing that I'm going to go over one of these with you so you can kind of see how it works. So if you go down to card 2 here, you are trying to look at each one of these situations and determine which one does not match. So I'm trying to identify the one that does not match with the other ones. So really what you're needing to do is go and find the slope and the y-intercept for each one of these situations. And the one that does not match is going to be the one that's wrong. So if Paul needs to remove flooring to his kitchen, he has 200 square feet of tile to remove, and he removes a square foot of tile every minute. So I know he starts out with 200 square feet of flooring, and he takes away a negative, and we represent taking away right by a negative, so he takes away 1 square foot every minute. So if we were to look at that as an equation, we would have like a negative 1x plus 200. But look, anything times 1 times x would just be x. So I would have y equals a negative x plus 200. And then if I look at my equation, I know my slope would be a negative 1 because we can always assume there's a 1 right there. My y-intercept would be 200. So I know that my description and my equation, they both are the same right now. So either my graph or my table is going to be wrong. So if I go over here to my table and to find my slope, I'm doing my change in y over change in x. So my change in y is 10. My change in x is 10, so 10, and I'm subtracting here, so that should be a negative. So negative 10 over 10 gives me a negative 1. And then my y-intercept here is 200. So, oopsie. So my y-intercept is 200. So far, that is matching with the other three that I have. And then if I look at my graph here, notice that my y-intercept is at 200, which is where it should be. That is correct. But if you notice on every single one of these other ones, my slope was a negative value. My slope was a negative value. But my graph is increasing, and that does not match what my slope should be. When I'm looking at this, my slope should be going down. So it should be going down should be going down in this direction instead. So the slope, they had the slope flip-flopped on this one. So they messed up with the slope. They graphed it with a positive 1 instead of a negative 1. So this would be the one that would be wrong. So you basically are going through, I gave you 4 to do. You basically are having to go through and find the slope and y-intercept of each one and identify the one that does not match the other ones. All right, if you have a question, let me know.